Okay, so we'll wrap this up by doing some very, very abstract problems. And so basically, what we have here is we don't even have a data table, we don't have a graph, we don't even have the function we're talking about. All I'm doing is telling you some basic behaviors of the function and then having you answer some questions about them. So very, again, abstract. So what we're told is we have a function called f, and its domain is from negative infinity to 3, and its range is from 8 to infinity. They want us to do the following. Find the domain of this new function, find the range of this new function. So there's lots of ways to handle this, but perhaps one way we can start to do it is by just what the heck's going on here. And so we have a function, right, that's defined from negative infinity to 3, and then from 8 to infinity. So maybe it's a function that looks like that. All right. So now I've given myself a nice visual of what this function might look like. Maybe it's a little more curvy or whatever, but there's what it is. So its domain is from negative infinity up to 3, and its range is from 8 to infinity. So now that we kind of made something abstract a little more concrete, we have a picture at least to manipulate. Let's do it. So how do I find the domain? Well, domain consists of all our x values. So how are our x values being manipulated? Well, looking at this 1/2, that manipulates y values. Subtracting 2 manipulates y values. So the only thing that's manipulating the x is this plus 5. And that's basically making everything move to the left 5. Right? And so that means I'm going to take this picture and everything's going to move over 1, 2, 3, 4, 5. So it's going to be moving over, so the picture will be the same, but it's going to be moved over, right, and start from negative infinity to negative 2. Of course, you can think of it as we just took this and subtracted 5 from everybody, right? Well, if I have negative infinity and subtract negative 5, I'm still negative infinity. If I take 3 and subtract negative 5, then I'm negative 2. So kind of back to the data points, I'm just manipulating the two major points in the domain. Or what I'm doing is just visually seeing that action happening. So what about the range? Well, the range, right, there's two things that impact it. First of all, we have a vertical compression by 1/2. And then we have a shift down, all right, by 2. And this is going to seem a little weird because of the infinity going on, but we're taking all these y values and cutting them in half. So that means that this value here is 8, right? That's what y is equal to. If I cut it in half, it's going to be now at 4. So again, you can kind of, the graph is going to be kind of collapsed down. Or what you can just do is take our values here and multiply everybody by 1/2. And so that's giving us 4 to infinity, which we kind of see there in my thing there. Subtract 2, well, that means I'm now going to subtract 2 from everything in here. So this becomes 2 to infinity, or on the graph, I would shift down 1, 2. And so it would come there. So we can see that the graph is starting at 2 and going to infinity. So I manipulated the graph to get it, making something abstract concrete, or I just manipulate the x and the y values the way this is telling me to do it. And so our new range would be 2 to infinity, and our new range is 2 to infinity, and our new domain is from negative infinity to negative 2. So that's how we do some abstract stuff. Number 11, again, we're a little bit abstract. Okay, I'm told as I have this function called g, and it has x-intercepts at negative 3, 0, and 4, 0. So before we do anything else, let's try to visualize a graph that does that. So one of its intercepts is at 4, 0, and the other one's at negative 3, 0. So perhaps we're looking at that parabola, right? So there's a nice graph that gives us a nice concrete understanding of what's given. So let's see what's happening. We got to find the new x-intercepts, right, for this new function y 2 times g of x. Well, the 2 only impacts the y value because we're basically have a vertical compression of a factor of 2. But the y value, right, if you look at the y value for each one of these, the y value at each component, y is equal to 0. So if I took 2 times 0, I will still have 0. So let me change pens here. This 2 is making everything stretch, right? So it's going to be a skinnier parabola, but the intercepts are going to stay put. So this guy will still have the same intercepts, -3, 0, and 4, 0. So nothing to worry about. What about the next graph? Let me even change colors. I'll change to blue. So what about the x-intercepts of the new function y equals g of x plus 5? Well, that is impacting x, right? We're basically moving everything to the left 5 units. So visually, right, this point here, right, which is a 4, 0, is now moving 1, 2, 3, 4, and 5. So it looks like it's now moving to -1, 0. As opposed here, right, this is moving over 1, 2, 3, 4, 5, and that's at the point, I think, -8, 0. So our new graph, would be like so. It's just been shifted over 5 units, which means all the x-intercepts went with it. Or you just take the intercepts that I have, right, and we subtract 5 from the x-coordinates, giving it that way again. So there's a numerical way to do it and a visual way to do it. So again, very abstract. I try to give myself a concrete picture, and then again looked at what type of transformation is occurring and see how they impact the information that's given. In this case, the x-intercepts. In this case, they impacted y, so the x-intercepts weren't impacted. In this case, we're shifting the x's to the left, so of course that's going to impact my x-intercepts. Last but not least, we're told that a function h of x is increasing over the interval 2 to 6. So again, before we start anything else, why don't we draw a picture of this? So here's 2, 3, 4, 5, 6, and so maybe I have a function that's doing that. All right, so it doesn't tell me how it's increasing, but I just gave myself a function that is actually increasing from 2 to 6. So over what interval would the function y equals x plus 3 be increasing? Well, that is impacting x values. We're basically going to the left 3 units. So this means that this picture, let me put it in red, this coordinate is moving over 1, 2, 3. So we're at -1. This is moving over 1, 2, 3. So we're at 3. And so this function basically shift over that far. So it's going to be increasing. If it's increasing on 2 to 6, it's going to be increasing on -1, 3. Of course, what you could have done also is you could have taken our data, and to go left, we basically just subtract 3 from both. These are x coordinates, by the way, right? And there's our -1, and there's our 3. So you either manipulate the points or you manipulate your graph that we're visually seeing to try to get a grasp of what's happening, make something concrete. Last but not least, what is the graph of y equals -x doing? Well, this is a reflection through the x-axis. So that means that this data point will be down here reflected, this data point will be down here reflected, and vice versa. And so it looks to me that on this same interval 2 to 6, it's actually decreasing. Okay, so that is how you can basically make something that's abstract, try to make it concrete and manipulate the pictures, or you can just manipulate the data like we just did with the data points previously. That wraps up 3.5. If you have questions, you better ask them. Otherwise, I'll see you on Canvas, or I hope to see you in office hours, whatever it takes to help you understand this very important concept of transformations. Talk to you guys later.